professional.
Yes.
We're gonna include this in the video. Hi.
Hi.
So
Functors.
what's that? What's a functor?
It is magic, child. Okay, a functor is basically a class type object that uses an overloaded parentheses operator to simulate a function.
What? How does that work?
So basically, you say comp, and you overload the parentheses. So you can pass in values, like for example, say you're comparing ints, you can do int A, int B. So what does this functor do?
Well, it returns true if A is greater than B, but why would we use that?
So functors are used in a lot of places in the STL. Every time you go in the standard library, you see like something called a unary predicate or a predicate. That's basically you can write your own predicate, which is a functor. So for example, let's say we have the function sort, right? Standard sort. And let's say we want to sort this, we pass in these iterators to, a vector. And we want to sort this vector. Now the default comparison operator that sort uses is less. So basically it will always, if you don't pass in any sort of predicate, it will pass, or comparator, it will sort the vector to be in ascending order. So like if you have 2, 1, 4, 3, that's your vector.
Yeah, you get
Right?
1, 2, 3, 4.
Yeah, exactly. But say you don't want that. Say for some reason you want 4, 3, 2, 1. That's why you use this custom comparator. That way you can just write your own, and when you pass it in, it'll spit out the vector sorted in the order you want. So you can override that less.
So how would we pass in the comparator?
So for the standard library, once you have this comp, right, you can just create an instance of it. So comp C, right? And then you can do standard sort, vector begin. I'm not going to write the full syntax. Vector end and C. Right?
And that'll sort it in ascending order?
Descending order. Because for this, basically it returns true if the first parameter goes before the second parameter. So in this case, it's true when the first parameter is greater than the second parameter. So that's why you'll always, when you use call sort on an array using this comparator, you'll always get something in descending order. So 4, 3, 2, 1, since each first value is greater than the successive value.
That makes sense. Can we use a comparator for other kinds of comparisons?
Yeah. You can use them for a lot. So you can write any sort of, thing in here. For example, if you want to see if they're equal, you can write, return A equals B, right? And then you can also use functors for other things as well. It doesn't even have to return a Boolean value. I know. It can return an int or a double or anything. So if you want to use a functor, for example, to perform an operation, but you don't know what the operation is yet. So you pass in the functor, like an instance of the functor here, and then all you have to do is return right?
Yeah.
And then, so basically op will take in this character when it's initialized. So before you call this function opper, you basically initialize an instance of O with some character, right? And then that character will tell O what operation. So the user can input, for example, a subtraction sign, and if you initialize O with that in like main, the functor can tell, okay, we need to perform subtraction, and when it calls oper, passes in that instance of O, it's going to automatically subtract it.
Nifty.
Yep.
Dope.